Welcome. We're going to talk about Math 30-1, Common Diploma Difficulties. I want to put you in the best position to be equipped to tackle the toughest questions you might see. So I'm presenting here a targeted approach to diploma preparation. Now, what type of questions, if you've ever asked yourself that, tend to be most challenging for students? Boy, she looks a little bit uncertain. Anyways, Alberta Education has identified a number of areas that usually results in a low correct response rate for students across the province who are writing the diploma exam. What's our plan here? Well, the Math 30-1 Information Bulletin of 2023-2024 includes a commentary on the Math 30-1 diploma examinations. Within this commentary, students' strengths and areas for improvement are identified. It is no doubt a priority for every Math 30-1 teacher to prepare his or her students in the best possible manner. Since these comments are based on the results of thousands of students across the province, paying particular attention to these difficulties would be prudent in terms of this preparation. So let's take a closer look at these areas for improvement. So in this video, I just want to touch on them, but I will give you a page link that has all of this information in more detail. And what you're going to find there would be 9 mini lessons addressing these 9 difficulties. And each has a video. It's about around 11 minutes. And each video or topic area of difficulty has about 8 practice questions, complete with detailed solutions. So here, what I would like to do is take these 9 and just quickly state them and give you a sample question about what it might look like about this area, this particular area. So number 1, using mapping notation to represent a transformation. As it said in the bulletin, stronger students are improving in their ability to represent a transformation using mapping notation, but weaker students still have difficulties using this notation. Question might look something like this. Given an equation, how do you write it where we're multiplying or adding or subtracting numbers to x and y? Mapping notation. Number 2, number of invariant points, those points that do not change from a transformation. Students continue to have difficulty determining the number of invariant points associated with different transformations. For example, given a graph, we're asked if this graph were to be reflected in the line y equals x, so the inverse function, the number of invariant points would be what? Now, I'm not providing solutions here. The solutions would be in the page that I'll be directing you to, but my goal here is just to give you a flavor of the types of things that students tend to have problems with. Number 3, restricting domain, so inverse is a function. Students have difficulty restricting the domain of a function so that the inverse will also be a function. Example, given an equation, quadratic equation, what can we do with this to restrict it so that the inverse would also be a function? Number 4, combining multiple logarithmic laws. Students are able to use the power law to simplify a logarithmic expression, but many students continue to have difficulty combining, that's the key word here, combining multiple logarithmic laws to simplify an expression into a single logarithm or to solve a logarithmic equation. Here's an example, 3 logarithmic expressions. Can we put them into one using the power, quotient, or product laws, and/or? Number 5, range of a rational function with a point of discontinuity. Students continue to have difficulty determining the range of a rational function that contains a point of discontinuity, such as this, where we have a common binomial in the numerator and the denominator. That tells us we have a point of discontinuity. What's the range of this thing going to be? Number 6, domain after the division of 2 functions. Students are able to determine the domain and range of a function after a transformation, but many students have difficulty determining the domain after the division of two functions. So for example, we've got f of x, g of x. They're both radical functions. Now, if we divide them, we have to be certainly concerned about restrictions as we divide, restrictions underneath the radical sign. Now, what would our domain be? Trigonometry, solving a trig equation using identity substitution. Students are able to solve second-degree trigonometric equations in a variety of domains, but many students have difficulty solving equations when an identity substitution is required. So using the formula sheet, having it right beside you, is there something that you can use that will help you make the process more efficient? So a question here, now it doesn't include or doesn't deal with double angle identities, but quite often we might see double angle identities. But a question something like this, substitution and then a solution. Number 8, combinatorics, permutations, combinations, problems with cases. Students are able to solve permutation problems that involve one or two constraints, but many students have difficulty solving problems with multiple cases. This or this or this, then we have to identify them, determine them, add them. Especially using something like at least, in this particular question, at least one girl in this scenario. How many cases would we need? Number 9, the binomial theorem with nonlinear terms. Students are able to identify the correct statements about the expansion of a binomial with linear terms. However, many students have difficulty determining specific terms in the expansion of a binomial with non-linear terms. So for example, 4 over x squared would be a rational function term, and that would be one of the terms in this binomial. So when we expand it with an exponent of 12, what would our constant term be? So just a quick summary here. This is a targeted approach to diploma preparation. Why not focus on those items, at least for part of the preparation, that cause the most difficulty for students? And as I said at the beginning, taking a closer look at these areas for improvement. So sometimes a greater awareness, a little extra practice is all what could make all the difference. As I said, there'll be 9 little video lessons and then practice questions you can test yourself, test your understanding. There's detailed solutions. Check those out as well. You'll find this page in the description below, or you can go to the Grand Math Connection, mathpqjq.com. It's also there. That's what it would be, addressing the Math 30-1 diploma difficulties. And as a last statement, I believe strongly you will be equipped to tackle the toughest questions on the diploma exam if you go through this document. And as you write your diploma exam, all the best of luck to you.